Hello. This is Postgres FM episode number 60. My name is Nikolai, and together with me today is Michael, as usual. Hi, Michael.
Hello, Nikolai.
And we are going to talk about what? Serverless or separation of storage from compute, or how do you name it?
Well, I think we had a really good request, and they used the wording decouples compute from storage. So maybe, even though I do like the short titles for the images for this podcast, I think that probably is more accurate to what we wanted to talk about.
Not
maybe
serverless.
I think serverless is part of this, but some of the other providers, I'm not sure. I think there are providers decoupling compute from storage that you probably wouldn't class as serverless.
Okay, I'm lost in this new beautiful world. I'm an old schooler, and I have my skepticism, but I also try to keep my mind open. So I'm trying to understand what's the hype about, and why. What is it? Why do we need it, and so on. So where should we start?
Great. Can I read out the question we got, because I think that frames it in quite practical terms. Says, what do you guys think about all these products that take Postgres and transform it to something that decouples compute from storage? For example, RDS Aurora, Google Cloud Alloy DB, Neon, etc. And then the follow-up to that was, do you see something like this landing upstream in the medium term?
To
so
Postgres
I think
itself.
Yeah, exactly. Which is I'm not 100% sure what they mean by that, how that would exist, but I think they're quite interesting questions, and they've basically asked for our opinions, I think, on those providers and anything else we'd class in a similar category. I think that's we've each had customers on at least one of those. I know Aurora DB is the oldest, so that's the one I've seen in the wild. But yeah, I've definitely read the marketing materials of the others and seen people playing around with them, seen some people excited by various aspects of some of them. So I think there are some compelling, at least marketing arguments, and it's an interesting future ahead. And then there's also the question of which parts of this, if any, could be upstreamed. For example, I know the Neon folks are working to make Neon as little of a fork as possible, trying to get some of the code upstream so that what they do is less custom.
Same as Aurora DB. Right?
Yeah, exactly.
Same approach.
So I think that's how I interpreted this question. How does that sound?
Yeah, that sounds great, but let's discuss what is it first, right? What is
So
separation let's discuss.
Well, let's talk about what some of these providers offer, or at least claim. And
Okay.
there's a few things that I'm not sure about all of them, but the things I keep seeing come up are around performance, are around scalability, and they're around things that aren't necessarily always that easy to do in Postgres. Like, for example, major version upgrades. So things that you can do potentially without the same consequences or the same downsides. So I've seen some good arguments that maybe the performance claims are slightly overstated by some of these providers, potentially not even the case once things are tuned differently. There's a really good blog post, for example, by the team at MigOps that I found interesting, comparing Aurora.
Let's discuss. What is separation?
Right.
So if I keep PG data on EC2 on EBS volume, which is network attached cloud disk, and have EC2 instance, I can upgrade EC2 instance just very quickly. Well, not maybe very quickly, but I can do it. If I run containers on that EC2 instance, or maybe if I have a layer or something, and for example, I get metal, and I touch EBS volume, and on metal I have multiple, I attach many volumes, and then I have, using Firecracker, like micro VMs, which can be provisioned very quickly, and then I distribute load of my huge instance among these smaller guys, I can change this micro VM very quickly. Is this separation? Why do I need to think about any Postgres changes at all? I have a network attached volume. Storage is already separated. What else? Like, why like, what are we talking about? What kind of separation? This is the question. What your materials tell you? What do they tell you? What
To be
do
honest,
they tell you? Yeah.
a lot of them gloss over this quite quickly, so I'm not quite sure like what would count, and maybe that would count by strict definition. But I think a lot of these providers, like let's say Amazon with Aurora, Google Cloud with Spanner and AlloyDB, those two, for example, have invested a lot in their cloud infrastructure and specifically storage. So they've got very good at replicating storage across regions with redundancy, with being able to put data close to users,
Right.
and that part of what they've invested in is at the disk level. That's at the storage layer. Now they've had interfaces to those things that aren't Postgres in the past. Like Aurora, for example, started, well, I don't know if it started, but it definitely had MySQL compatibility before Postgres compatibility. So it's added Postgres compatibility later. So that for me is is
Right.
one way of looking at it. So they already had this storage infrastructure that they had invested in, and they wanted to put a different interface on top so that they could support
Right.
people's applications that already had.
Right, but what I understand about this approach, they store my data directory in object storage, so S3, right? And then we need to, but it's if you just attach, there are some projects like that can, if you take your S3 bucket and then you attach it as like it looks like a disk in your Linux. It's possible to do like with Fuse or something, like it's possible, but it will be slow and bad and so on. Of course, in this case, if we want to keep our data directory in S3 and we need to work with it in like with good performance, we need also to cache it. So we need to cache it on regular EBS volume and so on. And as I understand, this is what Aurora and Neon do. Like might be mistaken here, like architecture. I'm not an expert here at all, but let's discuss about features for users. Of course, definitely.
Yeah.
Like if like bottomless, serverless, auto scaling. What kind of features? We have branching as well, right? So we separated and Postgres. I remember Aurora claimed one of the biggest benefits they achieved is lack of the need to care about checkpoints. So checkpoints are fully detached from our compute node. They are done in background. We don't care about them, so we don't have penalty from checkpoints anymore. We still have vacuum, unfortunately, in Postgres, Aurora Postgres, but we don't have checkpoints. And this is good in terms of if you have write heavy workloads, it's much better. So performance doesn't drops when checkpoint happens. Throughput doesn't, like latency doesn't spike, right? This is the benefit. What else?
Well, interesting. I actually didn't see that in the, at least on the front page. So that's super interesting.
But Aurora, well, it was
Yeah.
the original presentation on all Postgres conferences from Grant McAllister, engineer from Aurora RDS team, and he explained it very well. Like I recommend it even for those who don't use Aurora, because he explains problems with checkpoints and full page writes and details, and then how they solved. And not all technical details are clear there, but it's good for understanding of Postgres. These talks are good for understanding Postgres as well. And it was like 5 years ago or so. And so they don't have checkpoints. They eliminated. They don't fully eliminated them because they need to replay false and so like they need to take care of checkpointing still. But it's as I understand, but it's happening fully behind the curtain. So our compute node doesn't see any overhead of checkpoints. Right. So
let's take a few of the other ones, like storage auto scaling. So
I think by this moment, experienced engineers already understood that we are not experts in this at
of
all.
course.
But we are trying to understand this. Again, I'm quite skeptical. I see that it adds complexity a lot. This approach of separation. It's like let's append it or flip. How to say? We definitely can discuss further, and we will. But we have the question in the end. Do you see it will go to upstream to Postgres? Let me explain my opinion right now. I think yes, it has chances, but only after auto failover, pooler, and other such things, which are waiting to be included to Postgres engine itself. Because, for example, auto failover, it's all about multiple node cluster. So you have primary, you have replicas, and all auto failover is essential there. Postgres has improvements. For example, we discussed recently in libpq, fresh improvements in Postgres 15. I keep forgetting, or 14 even. This load balance feature. In when you connect, you can specify how to load balance and how. So these features exist, but it's kind of like making socket more better working for other tools, like for Patroni. For Patroni, we I mean, instead of including whole feature into the engine can be adjusted. So this feature, which is implemented externally using additional tool, the engine can be adjusted to work better. Same as with backup tools, there are improvements if there is API for backups now and so on. Maybe it means that PG Backrest and WolG will be in core in future somehow. Maybe not, still not clear to me. But what I'm trying to say, this separation might be seen as some adjustments, slight adjustments of things in Postgres, but I don't see how it can come as a whole thing into Postgres in nearest years.
I think I understand. Are you saying you don't think it should be included before those things, or you don't think it's possible, it makes any sense before some of those
adjustments can be made to separate storage from compute? For example, we know that EBS volume can be attached to multiple VMs if you use special file system, some Amazon file system. In this case, you can attach EBS volume to multiple EC2 instances. And this feels already less separation. You can have, I think they have snapshots. I'm not sure about full-fledged branching and so on. Maybe if you have snapshot and you create a new EBS volume, you already pay for 2 EBS volumes. And this is not as Aurora or Neon have. They have ability to have thin clone, and you don't pay. It doesn't increase the storage bill twice when you do it. In this case, probably it does. I mean, in the case of this Elastic file system, Amazon, I don't remember, this file system which supports attaching EBS volume to multiple EC2 instances. So money is a very important aspect here, for sure. But how come Postgres can support any of these things? I don't see, in the nearest years, I don't see it at all.
The only way I see it happening, with any, they even said in the medium term. So I guess it depends what you mean by that. The only way I see it happening is if some of these providers, like your Neons, get a lot of support for contributing what they want to do, maybe as hooks, or maybe making things extensible rather than it being in core. So it might be, I don't know if that's the same thing kind of in practice, but that's the only way I could see some things happening. I can't see the current Postgres core devs prioritizing this as a feature, partly, as you said, because there's so many other things competing for attention. And actually, it's not that many people in the grand scheme of things contributing to core. They've got relatively limited bandwidth and lots of good, important things to be working on already.
All right. So this answers the last question, but let's talk about again. Let's talk about.
So what do we think about those products? I can tell you what some of my friends fellow founders, other people, why they're picking Aurora, for example. So I'm not sure it's always the wisest decision for smaller businesses, but they like the appeal of auto scale up without downtime, without a lot of operational
Is it really without
overhead.
downtime? Because yesterday I
Well,
tried Neon and I wrote them. So like I had PG Bench running on auto scaling Neon instance, and every time it scales, I see errors. So maybe it's not polished yet, but this is hard, right? But I don't understand why we need to separate auto scale again. Like if this is breaks my mind. Like again, like I am old schooler. What if? Well, like it's funny, but considering ABS volume and EC2 instance and cloud, it's already old school approach, right? Because, like some like 10 years ago, it was quite new thing compared to on-premises setups. So I have EC2 instance, I have ABS volume, and I can quickly provision another EC2 instance. Imagine if I have PG Bouncer. All connections go through PG Bouncer. I have a certain instance. What if I issue pause to connections and quickly reattach my ABS volume to a new instance and then resume? And it has already more CPU and RAM.
Yeah, but I
need to
think
start
you're skipping over like having the operational confidence to do that and the experience to know that you can even do that. But that's not typically how people are self-managing Postgres, and it's not typically how.
But I'm trying to ask, why do we need to cut Postgres guts? I mean, to replace legs and so on. There's a common saying like Aurora, Neon, they replace the bottom half of Postgres, storage related half. They rewrite it. Why do we need to rewrite it?
Good question. So I think there's a few things. I think you mentioned cost, and there's an interesting argument for. I think people see Aurora at least. And Neon actually. This is one of their main selling points. There's a bit more pay as you go, so the cost increases slowly as you grow. Instead of if you're on, let's say RDS, you go up in jumps, right? You go from a smaller instance to a medium one to a larger one. Those aren't necessarily well. I can see you shaking your head.
Again, I can build managed Postgres service. For example, Supabase might go this route. I don't know. We can run it on larger Metal instances in AWS, and then we can use Firecracker to provision micro VMs, and then we have fine control about how much we can run. We can even run single VM and multiple containers and use quotas for containers in terms of CPU and RAM. Maybe even in Kubernetes.
So you're saying these things are possible, but that's not what people are choosing between. They're choosing between Amazon RDS, regular Postgres, and Amazon Aurora Postgres.
Right.
And when you're looking at that comparison,
RDS users can choose, right?
Yeah, so do you see what I mean? Like that. So this is the choice in front of people that want a managed service, and I think you could argue, I think with some merit, that Aurora is even more managed. So they'll do even more things are possible for you, maybe with a few more limitations.
Aurora has some good things that could go to RDS as well. They could go to open source area, for example. Plan management extension. But obviously AWS decided to keep it only for Aurora for competitive reasons. So this is clear to me. So this extension doesn't deal with Aurora special features. It deals with regular. You know it very well, right? This I don't remember
query plan
the name.
management.
Right. This is a good thing, and I wish it was open source. But
for anybody that doesn't know, that's I think it's a feature that's come from enterprise databases like your Oracles of this world. And if you've ever had a query plan flip, for example, data's grown in size and it's flipped from quite an efficient plan to one that's no longer efficient because because that plan now has a lower cost, basically. Aurora has a feature that allows you to avoid those flips with certain rules around. how much lower the cost needs to be before you change from an approved plan, that kind of thing. So it's a very, very interesting feature.
Which
but yeah,
wouldn't,
you-
which doesn't require separation of
Very
compute and
true.
storage at all, because it's only about the planner behavior.
Yeah. But my point is that people aren't choosing separate compute and storage. They're choosing the product. So
It's
that's,
just
I think,
because of decisions of Amazon business guys. That's it.
yeah. Right. So let's say Neon, for example. I think that is much more clear cut. People are excited, I think, because it's because you can start by paying zero. There's a free tier, and you can start by paying very little.
First of all, I think Neon example shows how open source can get all benefits that non-open source guys like you, by the way, try to hide from us. You understand the thought,
Here we
right?
go.
So,
Go on.
so I mean, Aurora is like, it's positioned like as a replacement, like it's for those who migrate from Oracle. This is alternative, and we know Amazon itself migrated from Oracle to, as I understand, Aurora Postgres, and it's good, like great, and this is like serious Postgres position. But now Neon is making open source version of the same thing, and my general thought, those managed services guys who like RDS, first of all, they say, okay, we automate backups, UI, everything. Wait a few years, open source versions of it will be maybe even better. And we already saw like Stagris, for example, good UI and so on. And it's open nature, so you can, we discussed it in previous episodes, self-managed. And what I'm trying to say, like you can, if you don't go open, it's a mistake.
Well, yeah. This is really interesting for commercial, like as a commercial discussion, but I think there's also an interesting thing for as a customer. If you choose Aurora Postgres, for example, and start relying on the query plan feature, what are your options for migrating? You're kind of stuck there until there is an open source alternative.
Just one of the features, and eventually community will have this feature as well. Somebody will implement this plan manager
so
in open fashion.
I think you're right. I think you're 100% right. And I think Oracle, for example, are losing market share to Postgres, but Oracle still makes so much money per year. It's not like they're going to zero really quickly. So it's an interesting discussion. I think there's a lot of ethics and morality at play. Like there's a question of you can be open and have bad morals. You can be closed source and have good morals. I think we know where we both think Oracle are and where we think some of these newer providers are.
It's not fully clear yet for new providers because they're super young yet. And for database, like a couple of years is nothing.
Yeah. And I think it is a bit different if you're a platform versus if you are a GUI tool. So I think I've mentioned this to you previously, but the reason my tool's closed source is because I don't see another business model for it. There's not much support for it, and the UI is most of the value. There's no service that adds a lot of value. It's just a UI. So if we made it open source, anyone could host it for free, and there'd be no need to pay us ever.
It will give warranty that it won't die.
Yeah, sure.
Because for example, if you or Neon company or if my company is closed, our tools, like if we don't open source them fully, it will be hard for people to continue using them. And this applies to you. This applies to me as well. By the way, I promised last time I'm going fully open.
Yeah.
Everything will be open. I'm still thinking like, yes, we will do it. We just released 3.4 database lab engine, DB lab engine now it's called. And 3.5 will be fully Apache 2.0, including everything we try to keep only for paid customers. No, we will have everything open. And I suggest Neon to think about this approach as well, because they keep some pieces not open, and this is for sure strategic move and so on. So control plane, automation, not fully open. And this is a very difficult decision if you have a lot of money raised, right?
Yeah. Well,
So
even if you don't have a lot of money raised, if your ambition is to build a business around it versus your ambition is to build, if there were people in the past that
competitive,
have been
right?
in,
Right.
but there were people in the past that have built databases because it's academically interesting to them.
Right.
And if that's your goal, making it as open source as possible makes a lot of sense. But if your goal is to build a business, it also makes sense to prioritize commercials. Like I do on like it's interesting to think about.
In this area, I recommend listening Michael Stonebreaker's speech when he received this award. How's it called? This reward, a Turing reward, right? So yeah, he compared like riding a bicycle, uphill, downhill, and he has a lot of experience in both purely
True.
academic products and like academic research projects, and also building companies and for profit companies. So this is interesting area. But if you want your thing to live longer, you need to make it open. I think we moved away from the main topic.
Very much so. Let me quickly go through a few other things that I think people might want to read up on or watch. You did a good interview, I thought, with somebody from Neon. It was
Stas
Stas Kel.
Kelvich?
Yep. On Postgres TV. I'll link that up in the show notes. And another one with somebody from Cloud Spanner about their Postgres compatibility
Partial
there,
support of Postgres syntax.
which is actually something I did want to cover here, that a lot of these systems are Postgres compatible, which I mean, it makes sense, right? Because they've literally taken out the storage layer. You probably can't say any of them are Postgres.
None of them are Postgres.
Well, yeah, but if you read Neon's landing page, you'd be very forgiven for thinking it was, right. Like it says serverless
Yeah.
Postgres. Everything's Postgres. So what I meant is, if you're looking into these systems and considering using them, check what they mean by Postgres compatibility.
Yeah.
Will what you want to use work? Are the extensions you want to use available? Is the syntax you want to use available?
What kind of
Which
wait events they provide? Because Aurora has their own, its own specific wait events. By the way, I still consider wait event documentation of RDS and Aurora RDS as the best. But have you seen for Postgres 17 probably already? The dictionary of wait events will be provided as a system view, like select start from PG
Oh, great.
PG
No, I
wait
didn't see that.
events or something, and you see with explanation, a list of events with explanation. So it's good. Not only in
Great.
documentation, but right in your Postgres. Good.
Well, hopefully in the documentation too, but if not, great.
Documentation has
Still-
it, but it doesn't. It's not as well explained as RDS
Oh, got it.
documentation.
Okay.
Because it's very like short. Like this event type, event wait event type, and just one sentence, and that's it. But RDS has whole page with practical pieces of advice.
Yeah, I remember now, and I remember not realizing that the first time I saw the page because I didn't realize you could click on each.
Yeah. Well, it's
each
a
one.
UI issue, UX issue
Yeah.
in RDS docs. But I mean, if it has different wait events, it means for advanced users, it means it's managing will be different, right? Slightly different. So it's
Yeah.
already not Postgres; it's deviation.
And this is what I mean by do your research, check that what you want. Like,
Right.
just don't assume that if you're using Postgres already, or if you've used it in the past and you want to use certain features, don't assume they'll be available on these providers. Check. And then the last thing I did want to bring up, which is in this area, was the feature timescale announced. So timescale, I'd argue, is Postgres.
Bottomless.
But yes, but they're on timescale cloud specifically, not. I mean, it kind of makes sense that it would only be available in the cloud option. They allow you to transparently, without changing how you query the data, move certain chunks. Which is partitions, but they call them chunks, to object storage on S3. And the arguments they give for it are reducing cost. So that's an interesting. Maybe that's like the true root argument is that
Here I
in
see
theory it should be
potential.
cheaper.
Yeah, here. Well, of course, if you first of all, if you S3 is like virtually infinite, EBS volume is always limited. Even it's like I don't know, I don't remember last new limits 64 terabytes or maybe already more than 100. I don't manage databases more than a few dozens of terabytes, so I'm not that experienced. I don't have 100 terabyte Postgres
Still
instance
bigger
yet.
than most, but yeah.
I think it will happen in the next few years, actually, but not yet. So offloading data to S3 is very good. Actually, ZFS project had an issue in there, OpenZFS for Linux. They had an issue discussing this feature to transparently move data to S3. And they developed it. I mean, Delphix developed it, but they decided not to open source it yet, unfortunately. But I think this is exactly where there is some potential for Postgres maybe to support something, to move some partitions to object storage. This is an interesting idea, or to offload them to different machines. You need to think about consistency checks here, right, and so on.
Yeah.
This is opportunity for Postgres itself to develop some universal solution which will work with various clouds and maybe even on-premise, and will help you to have this bottomless feature. This is a good example because it doesn't require to redesign half of Postgres, but it requires some redesign at least. Because if you moved it and then suddenly we know S3, if you don't mark some checkboxes, it's very reliable in terms of it doesn't lose data, but it's not very highly available as ABS volumes, especially like regional and so on are. So they might be not available, and you will see like some corruption errors, like Postgres cannot read some partitions and so on. And this should be handled properly if you move data to S3. Because
I agree. I just am struggling to understand how Postgres could bear in mind that's quite provider specific.
I just see it's easier problem to solve and beneficial for wider audience, not only AWS users.
Yeah. A couple of things to mention on the timescale
You can
thing.
install S3 as Minio project. You can install it yourself. I mean, to build some data center and so on, cloud repatriants, right? So those who migrated back from clouds to like we know, like Basecamp, right?
Yep.
So
by the way, I'm not sure they moved the S3 back. I think that might
who
still
knows,
be.
but I think this wave is obviously starting to grow for those who want to optimize budgets. And in this case, if you know you in Postgres, you can mark some old partitions to be stored out of your hot disk, which is limited and quite expensive and so on. Maybe even to disk. Already now you can move partitions to colder disk if it's on the same server. It's all very old approach. And you can automate it probably and so on. There is some opportunity here. And you can achieve this bottomless feature. I want a petabyte database, maybe. I don't want to erase data.
On timescale, you've got the double benefit of it supporting compression as well. But
that is a different story.
But just for completeness, I guess the main trade-off then is read performance. So you've moved it to S3 for cheaper storage, but if you do read it in future, presumably your queries are going to be quite a lot slower.
Of course, right. It's quite a lot of slower. And in case of, again, if to remember ZFS, if this feature someday lands into ZFS, ZFS has different types of cache. One is regular ARC, ARC. It's like file cache locally on machine. But there is also ARC2, ARC2, which allows you to, for example, Heap Analytics, they had very good article like 5 years ago or so. So they wanted very good performance. They wanted to use local ephemeral NVMe disks. I think it was time when EBS volumes were not NVMe based, not Nitro architecture. Now they are. But that time, and actually, local disks will be always faster, definitely. But they are ephemeral. If you restart, you may lose data. So what they did, they used large EBS volume, slower but large and reliable, so that if restart happens, you don't lose data. And using ZFS ARC2, they put cache on local ephemeral NVMe disks. Smaller, very fast, and also ephemeral, meaning that you can lose them, but you can rebuild this cache transparently. Automatically, ZFS will do it for you. And this also sounds for me like separation of cloud and compute. Imagine if this happens, if ZFS will start working in the same way with object storage like S3, infinite storage in S3, and local caches using ARC2. Very good feature. And you don't need to rebuild Postgres to benefit from it, because Postgres relies on underlying file cache as well. So like it's working on upper level. Very interesting. So let's maybe try to wrap it up. And what are the main benefits for users which this separation claims to provide? First is like serverless, so faster change of is serverless auto-scaling or no?
So, I struggle with definitions, to be honest with you. My understanding is there's a couple of features of serverless that people love. One is scale to zero. So if you're not using it, you pay nothing. This
doesn't require any changes. You just need the proxy, like maybe smarter PG Bouncer, which will start your node. And you need probably Firecracker to start node faster. So that's it. Why?
I don't mean serverless Postgres, by the way. I meant serverless anything. That's my understanding.
Right. But scale to zero doesn't require separation. I mean, EBS volume already separated again. Like I don't understand. Sorry. Like I don't understand scale to zero part.
Regardless, I think it's clear if we want to go into any more detail in any of these, we're going to need to invite somebody else on to talk to or learn a lot more about it ourselves. I hope that's answered the question for the person who requested this somewhat. That's what we know. And I also think if you're a general user of Postgres and you don't have any problems, you don't need to worry about any of this. Like I don't see any reasons why we can't work on like regular Postgres. The reason we don't know that much about this is because most people don't need this.
Let's list all the things. So the scale to zero, good. Understood. I'm not convinced we need to rebuild half of Postgres. I think it's achievable with regular Postgres. It's just a matter of how fast you can shut down is not important, but how fast you can start your compute part. And that's it. This is the main part. Postgres doesn't need changes. Maybe I'm missing something. Again, like my skepticism is not final. Like I keep mind open. I try to understand. Second is this bottomless feature we just discussed, right? So like limits are much higher. You're not limited by single EBS volume anymore because you use S3, like a lot of stuff there. Good. And again, I just described maybe there are chances to achieve this as Timescale did actually already. You don't need to to rewrite a lot of Postgres. Maybe we will have it for more cases, but it's a good feature, I think. Third is probably database branching, which Neon has branching, Aurora they have only thin cloning, because what was difference is simple: thin cloning plus ability to commit or like to make a snapshot and then to claim now you can start new clones from that point. This is already branching. And Aurora, they has only thin cloning, as I understand. Neon has full-fledged branching API, not really close to Git, but very like full-fledged. So my big concern about their implementation that they provide budget benefits only for storage part. So if I run 10 clones, I pay for 10 compute instances. And this means that they close doors for good CI testing, both products. I want sane bill. I mean, we discussed it. I want sane bill for my CI/CD pipelines. If I run many of them, I don't want to have big O of n bill, where n is number of pipelines. I want big O of 1. Constant price, and this is what we achieve with ZFS with DB Lab. So again, like maybe And we don't replace Postgres. Postgres is the same. We just replace file system. Do you need?
I think if you want a constant bill, serverless is not for you. I think that's fair to say.
Right, but what sounds appealing is scale to zero, and I'm exploring this to add this to Database Lab. I see how to do it, so we probably will do it, because if somebody is not working, especially for physical approach, I just learned that unlike VaultG, pgBackRest has incremental delta restore, so you can sleep for many days, then wake up and restore physically only delta of physical PG data changes. This is great. So you don't need to replay walls, it's very slow. If you accumulate 3 days of walls, replay will take some time for heavy loaded system. If we talk about to apply delta physical backup, that's great. So I mean, we can achieve very good behavior here. Of course, Neon characteristics are very good, but again, system is quite new. So, and maybe fourth and final one, auto-scaling to both directions, not to just zero, but between like. By the way, do you know why Neon compute units are limited by 7 only?
No, I don't know.
Yeah, that's an interesting question. 7 doesn't seem big enough for me.
I think they've started. I think with new systems, it's really sensible to start aimed at startups, because if you like the difficulty with databases is a lot of people choose it based on reliability, based on, you know, if we're talking about the storage layer of Postgres, that's arguably its best feature. You know, we choose our database because we want it to be reliable and battle tested, and it's got decades of track record there. So if you're a new system with a different underlying storage mechanism, you're probably best off aiming your service at people who can take a bit of a risk because they've got nothing to lose. They're a new startup. They are enticed by, oh, it's going to be free at first, or it's going to be really cheap as we scale. So I think it's a really smart strategy to go small first. I think Supabase have done the same. But as they get more serious, as those startups grow, they can gradually appeal to larger companies. I think it makes sense. Yeah. Mm-hmm. But equally, I don't know, 7's an odd number, right? Like, I would have expected it to be a multiple 2. I have no idea. They're very smart people running it, so I imagine there's a very good reason. I have no idea. Okay,
and but I want to ask about this auto-scaling. You as a specialist in query planning, what happens if, first of all, I hope they will fix it. I'm sure they will fix it. I never tried it for Aurora serverless. When auto-scale happens, my pgBench shouldn't be disconnected. It shouldn't experience errors. And the same with my application, right? So it should be seamless. Yeah. I think this can be achieved, and that's great. I mean, consider this is solved. But I wonder what's happening with Query Planner and its settings, because if we jump from one, for example, from one CPU and some RAM to much bigger instance, Planner settings should be adjusted. We have bigger cache, right? But this I don't understand. But I think Neon is special, and I'm sure they think about it. I just don't understand how I can manage my performance settings, database configuration, when it's quite unpredictable in terms of how big instance is at any given point of time. What do you think about this problem?
Yeah, I guess it's stored alongside I guess it knows when you're connecting to it, like what it has available, and therefore what its settings are. I have no idea if they control that for you, or if it's configurable on can you set various limits as to what, can you set your, let's say, work mem, can you say when I'm provisioned to a small instance, set it to this, and when I'm on a medium instance, set it to that high number, and when I'm in a large, can I set it to an even higher number? My guess is they haven't got to it yet, but I actually have no idea.
I would like to have more control and predictability than the unpredictable changes. And I actually know what, maybe Aurora implemented this plan management feature exactly because with auto-scaling and serverless approach, we need to freeze plans, maybe. Who knows?
Oh, we're guessing. I have no idea.
Yeah.
But if you've been involved in that, that'd be really interesting to hear from you.
Yeah, you mean me or listeners?
Anybody listening?
I'm joking. So maybe it's time to wrap up. I think we just started this discussion. It's very interesting.
Yeah.
I'm far from understanding it fully. So I appreciate if people share their thoughts, and we can continue another time. But it's it's very interesting. I'm just an old schooler, and I rely on things I know how they work, though I don't know how they work fully always. So yeah, I mean Postgres itself, it's so huge system, you never know how it works fully, but I do my best. So yeah, please share this episode with others as usual, and we need support as usual to subscribe in YouTube, on all podcast platforms, and likes, comments, we appreciate everything. It helps us grow and see also signals that it's interesting to continue.
Nice one. And thanks for the suggestion. We've had a few more suggestions as well, so we appreciate those coming in.
Thank you.
Nice one. Thank you,
Till
Nikolai.
next
Take
time.
care.
Bye-bye.
Bye.